Now let's see an example of multiplying two numbers, binary numbers. So I'll just take this example. Let us say one number is 0101, which means its decimal equivalent is 5, and I'll take one more number. Let's say the number is 0110, its decimal equivalent is 6. Now if I multiply these two, the result should be 30. Now how do you normally multiply using a pen and paper is that partial sum method. So I'll just explain you what we generally do, and then we shall see how to improvise it. So let's say this is multiplier. Now multiplier is generally represented by Q, and this is multiplicand. So multiplicand is represented by M. So that is the general convention, right? Multiplier and multiplicand. Now we generally take the multiplier's least significant bit, and then we multiply the entire multiplicand, and we write the partial sum there. That is the procedure that we are going to use. Therefore initially I take 0 and I multiply this, then I am going to get 0 only, right? I am going to write it, and next thing is when I multiply with 1, I am going to get 0101, and see, if you observe it, the next time when I write it, I am just shifting it and I am writing it. Okay, that is important, one observation you should make. And next time when I do this with 1, again I have to shift it and write it, and again if I multiply with 0, I have to shift it and write it, right? So now if you observe it, 0 1 1 1 1 0 0, right? 1 2 3 4 5 6 7. So if I am going to multiply two n-bit numbers, in worst case the space required to store the result, if I multiply n bit by n bit, the worst case space required to store the numbers is going to be 2 power n and not beyond this, right? So if you multiply two n-bit numbers, so let us say sorry, this is 2n, right? So if I multiply two n-bit numbers, then the space required to hold the result is going to be 2n, right? In worst case, you need not go beyond that. So one observation you can make there. So now let us say we have to multiply two 4-bit numbers, then this worst case space required will be 8 bits. So in this case 7 bits were enough, but in general 8 bits, right? So now how to implement it in a computer is, one simple method is, maybe for every partial sum you can have a resistor. So you are going to have 4 resistors in that way, and you are going to add all those 4 resistors to get it. That is one method. Other method is, if you want to improvise it, instead of using 4 different resistors, you can have only one resistor, and on that resistor you can do addition and shift. That way you can implement it, right? Let's see that method now. Now let us say we are going to add, we are going to multiply the same number 0 1 1 0, right? So now what I do is, I am going to have 8-bit resistor. Let's say 1 2 3 4 5 6 7 8. Let us say 8 bits. 1 2 3 4 5 6 7 8. 8-bit resistor. Why 8-bit resistor? Because when I multiply two 4 bits, the worst case result may be 8 bits, right? And let us assume that initially we are initializing it to all zeros. Now initially I'll write this, I'll multiply this one with this one, and whatever partial sum I get, I'm going to add it to always the most significant 4 bits, right? So if I multiply this one with this one, I get zeros, and if I add 0 0 0 to the most significant part, 0 0 0 0, I'm again going to get zeros only, right? Okay. And now next thing is, when I multiply 1 with this, then I'm going to get 0 1 0 0, right? In that case, again I am going to add it to most significant 4 bits, right? See, after every multiplication, you are going to add to the result here, and again we are going to shift, right? So now if I multiply this one with this, the result I am going to get is 0 1 0 0. So that is why 0 1 0 1, sorry, 0 1 0 1, I am going to write it here, and I am going to add these two, right? So what do I get? So here I get 1, right? And here I get 1, and after that you are supposed to shift it, right? Shift right. So one shift right if I do, then what do I get here is 0. So shift right also you have to do it in arithmetic shift. So 0 0 1 0 1 0 0 0. Got it? So now if you observe it, what we got is this part. right? So if you add these two, it is going to be 0 1 0 1, right? So 0 1 0 1, got it? And again, if I multiply this one with this one, so what is that we are going to get? 0 1 0 1, right? Again you add it and shift it, so what do I get? 0 1 1 1 1. Now you have to shift it once, so you have already 3 zeros. If I shift it one time, I am going to get 0 0 1 2 3 4 0 0. Now what you got is a result when you have added these three, right? And now again, if you multiply with this, then I am going to get all zeros, so you are going to add all zeros to this, right? 4 zeros. And now if I add it, you get the same number, and if I shift it, after adding I am going to shift it, right? So 1 2 3 1 2 3 4 0, right? So if you observe it, this is the result what we wanted, right? The same result is present there, right? So now using this method, you can use only one register, and you can always add shift, you can do that way. Now when is the addition required? Whenever in the multiplier, whenever there is 1, you are actually adding, isn't it? See, adding zeros is not actually adding, you can leave it that way. So for every bit in the multiplier, you are going to apply one shift in this register, and for every 1 in the multiplier, you are going to apply one addition, got it? Therefore in this method, how many additions are required in order to multiply two numbers? The number of additions required is equal to the number of ones in the multiplier. And how many shifts are required? The number of shifts required is equal to the number of bits in the multiplier, got it? If you assume that there are n bits in the multiplier, then you have to shift n times. So n additions are required and n shifts are required. Now we shall see one more algorithm that will be able to perform better than this in terms of the number of additions required, right? See, let us say in this case 0 1 2 3 4 5 6 7 0. How many ones are there? 7 ones are there, right? So in order to do this, if we have to multiply with any other number, the number of additions required will be 7, right? And the number of shifts required will be 9. But then if you are going to use Booth's algorithm, it will be better. So let's see how Booth's algorithm will be able to reduce the number of additions required in this case. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have, you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.